number line. The number we're graphing, -3, I'll put in the middle of the number line. And we'll put one number on the right of -3, which is -2, and one number on the left of -3, which is -4. For the circle again, you can either have an open circle or a closed circle. In this case, we have greater than or equal to. Anytime you have the or equal to or line underneath the inequality, the circle will be a closed or solid circle. And the last part to the graph, the line either goes to the left or to the right. In this case, greater than or equal to, the line will go to the right. And that's the graph for y is greater than or equal to -3. Title of the next section notes is solving and graphing inequalities. In this section again, we'll be solving first, and our answer will be able to graph the inequality on a number line like the previous section. First question is n plus 4 greater than or equal to -7. And again, we'll solve the inequality. After we solve, we'll graph on a number line. We have n plus 4. To isolate n or solve for n, we want to get rid of the plus 4, which we can subtract 4 on both sides. The 4's would cancel. The inequality stays the same when you subtract numbers. -7 minus 4 would be -11. And our answer n is greater than or equal to -11. Second part again, we'll graph each answer. -11 put in the middle of the number line. To the right of -11 is -10, and to the left is -12. Again, for these graphs, we have open circles or closed circles. Anytime you have the line underneath the inequality or equal to, that means it's a closed or solid circle. And n is greater than or equal to -11. Greater than or equal to would be the numbers to the right. Second question and last question for the section. 3y plus 6 divided by 2 is less than 3y plus 6. Solving this equation or inequality. At the beginning we have variables on both sides, so we want to move those over to one side. Also we have a fraction that contains a variable y, so we can cancel out or get rid of that fraction. If we have 3y plus 6 divided by 2, what we can do is multiply by 2. That way it'll cancel out the fraction, and the right side of the inequality will multiply by the same number, multiplying by 2. The 2's on the left-hand side would cancel, so we're left with 3y plus 6. If we multiply by a positive 2, the inequality stays the same. And distribute out the 2, we'll be left with 6y plus 12. From here we can solve. Putting all the y's on the left-hand side, subtract 6y. 3y minus 6y would be -3y. Plus 6 less than 12. These 6y's would cancel. And subtracting 6 on both sides, -3y less than 12 minus 6 would be 6. And the last step, divide by negative 3. Negative 3's would cancel. And one extra step on this part, when you divide by a negative number, the inequality would switch directions. 6 divided by negative 3 would be negative 2. The rule on inequalities, if you divide by a negative number or if you multiply by a negative number, the inequality would flip. So our answer y is greater than negative 2. And again, the second part, we'll graph each one of these. Negative 2 will be the number I'll put in the middle of the number line. Negative 1 goes on the right, and negative 3 to the left. We have open and closed circles. This one is greater than. Greater than would be an open circle. It's not equal to. And y greater than negative 2, greater than or bigger numbers go to the right. Title of the last section today is Write and Solve an Inequality. First problem for this section is the product of 12 and a number is greater than 36. Some math vocabulary. The word product means to multiply. So it'll be multiplying 12 and a number. A number is a number that we do not know yet. Anytime you have a number that you do not know in math, you can use the variable x. Is greater than would be the inequality greater than 36. To write the inequality, we'll have the product. Again, we're multiplying 12 times a number, or 12 times x, which would be 12x. Is greater than would be the greater than symbol, and greater than 36. So the inequality is 12x greater than 36. Second part, we're going to solve the inequality. 12x, you can divide by 12 on both sides. And we'll be left with x. The inequality stays the same when you divide by a positive number. Only switches when you divide or multiply by a negative number. 36 divided by 12 would be 3. And our answer is x is greater than 3. Second question and last question for the section. 3 less than twice a number is at most 5. Some more vocabulary. 3 less than, the phrase less than without the word is in front of it. Less than would be smaller, or the operation subtraction. Twice a number. Twice means to double or multiply by 2. And again, the phrase a number we can replace with a variable like x. Is at most 5. At most means the biggest it can be is 5. So the answer will have to be 5 or a number less than 5. To write the inequality, 3 less than again means we'll be subtracting 3. When we subtract 3, that'll come at the end of the expression, minus 3. We are taking away 3 from twice a number. Twice again would be double or times 2. And a number that we don't know, we can use the variable x. So 3 less than twice a number would be 2x minus 3. Is at most 5. That means the highest it can be is 5. It must be 5 or less. In terms of inequalities, that means it has to be less than or equal to 5. So the inequality 2x minus 3 less than or equal to 5. And the last part, solving this inequality, solving for x. We can add 3 on both sides. 2x is less than or equal to 8. And dividing by 2, x. The inequality stays the same, less than or equal to, whenever you divide by a positive number, 4. So the answer x is less than or equal to 4. Title of the first section of notes today is Solving and Graphing. Absolute value. Inequalities. In this section, we'll solve the inequality and graph the absolute value inequality. First problem, absolute value of x is less than or equal to 4. To solve a absolute value inequality, the absolute value again you want isolated by itself, which in this problem it is. And one way to solve this is you can remove the absolute values. So we'll have x less than or equal to 4. And also the inequality less than or equal to. We'll copy exactly as is to the left-hand side of the problem. And the number 4, we'll do the opposite of that, which is negative 4, that we'll put on the left-hand side of the problem. Now we have the inequality negative 4 less than or equal to x less than or equal to positive 4. From here we can graph the absolute value inequality, which again will be a single number line since we have a single variable. We do have two numbers in our solution, so we'll have negative 4 on the inequality, which I'll put on the left hand side, and we'll also have positive 4 on the right hand side. You can fill in some hash marks, so we'll have 0 in the middle. And from here we can graph with the open circles and closed circles. For the negative 4 value, negative 4 is less than or equal to x. Less than or equal to means it will be a closed circle above the negative 4. And for the positive 4, we have x is less than or equal to 4. Less than or equal to means, again, it is solid above the positive 4. So absolute value inequality graphs will have 2 points for the two numbers for the solution. We'll have 2 lines also. Each point can either go left or right, depending on the inequality. If we have negative 4 less than or equal to x, this means negative 4 is smaller than or less than x, or vice versa, x is bigger than or greater than negative 4. Bigger than or greater than would go to the right. Also for the positive 4, we have x is less than or equal to 4. X less than or equal to 4 means smaller than 4, so this will go to the left. When we have the 2 lines pointing towards each other, we can connect them, and the solution for this problem would be the numbers from negative 4 to positive 4, all the numbers in between, including negative 4 and positive 4. Second question, and last question for this section. Absolute value of 6a minus 3 is greater than 21. And again, solving absolute value inequalities, the absolute value must be by itself. And to get our inequality so we can graph, we can remove the absolute value. which is 6a minus 3. Greater than 21 stays exactly the same. And again, the greater than symbol will copy to the left-hand side of the expression. And 21 we'll put on the opposite side, but we'll also make it the opposite of 21, which is negative 21. This equation we have to solve. We have to isolate a by itself, 6a minus 3. We can get rid of the minus 3 by adding 3. When you have a compound inequality like this, we'll add 3 to the middle section, we'll add 3 to the right-hand section, and we'll also add 3 to the left-hand section. Negative 21 plus 3 would be negative 18. The inequality stays the same when we add numbers to each side. 6a would stay the same. Negative 3 and plus 3 would cancel. Greater than inequality stays the same, and 21 plus 3 would be 24. And the last step to solve 6a, to get rid of the 6, we can divide by 6. And again, we'll divide the right hand by 6 and the left hand side by 6. Negative 18 divided by 6 would be negative 3. The inequality stays the same when you divide by a positive number. 6's would cancel. We'll be left with a in the center section is greater than 4. So the solution to the equation or the inequality, negative 3 greater than a is greater than 4. Last part, we want to graph. Draw the number line, and we want the numbers negative 3 and positive 4 on the number line. I'll put negative 3 on the left hand side. We'll go up to 0, and we'll continue up to 4. To graph each of these, negative 3 is greater than a. Greater than means there'll be an open circle above negative 3. And a is greater than 4. Greater than, again, will be an open circle above 4. For the directions on the line, negative 3 is greater than a. Negative 3 greater than a means negative 3 is bigger, a will be smaller, or a is less than negative 3. Less than negative 3 would go to the left. And the second part, a is greater than 4. Greater than 4 would go to the right. So in this case we have our two numbers, negative 3 and positive 4. The solutions though are all the numbers less than negative 3 or all the numbers bigger than positive 4. Title of the next section is Solving and Graphing. Compound inequalities. In this section, we'll continue to solve and graph inequalities. Compound inequalities means we'll have two or more inequalities on each question. First question, we have x plus 1 greater than or equal to 5, and x is less than 12. For this compound inequality, we'll solve each inequality and then graph both of them on a single number line. Solving the first inequality, x plus 1 greater than or equal to 5, we can subtract 1 on both sides. So this would be x is greater than or equal to positive 4. The second inequality, x is less than 12, is already solved. Both of these are solved, then we can graph on a number line. Again, we want the two numbers 4 and 12. So I'll start with 4 on the left-hand side and then go up to 12. X is greater than or equal to positive 4. Greater than or equal to is a solid dot or a closed dot. X is less than 12. Less than would be a open circle or close. X is greater than or equal to 4. Greater than, again, would go to the right. And X is less than 12 would go to the left. When the two lines again point towards each other, connect them to make a line. And that would be the graph for the compound inequalities. Most of the time when you have the word and in a compound inequality, the word and means the lines will connect. But again, that's only most of the time. Second question, negative 2c plus 1 greater than 5. Or 3c plus 2 greater than or equal to 5. Again, we'll solve each one of these and then graph them on the same number line. First inequality, we can subtract 1 on both sides. Negative 2c is greater than 4. And dividing by negative 2. Greater than, since we're dividing by negative 2, anytime you divide by a negative number, the inequality will flip around. And 4 divided by negative 2 would be negative 2. So c is less than negative 2. The second inequality, 3c plus 2 greater than or equal to 5. We can subtract 2 on both sides. 3c is greater than or equal to 3. And dividing by 3. If you divide by a positive number, the inequality stays the same. So we have c is greater than or equal to positive 1. And again, each of these will graph on the number line. We have negative 2 and positive 1. C is less than negative 2. Less than would be an open circle. C is greater than or equal to positive 1. The or equal to makes a closed circle for positive 1. C is less than negative 2. Less than would go to the left. And C is greater than or equal to positive 1. Greater than would go to the right. On this one we have 2 points. One goes to the left and one goes to the right. Most of the time when you have the word or in the original equation, or usually means that they point opposite directions. Next problem for the section. A plus 2 greater than or equal to negative 2. Or A minus 8 is less than 1. Solving the inequality, we can subtract 2 on both sides. So we have A is greater than negative 4. Second inequality, we can add 8 on both sides. So we have A is less than 9. Graphing negative 4 and 9 on the number line. Negative 4 would be an open circle. 9 would also be an open circle. A is greater than negative 4, which means it'll go to the right. And A is less than 9, which means it goes to the left. On this question, both the points point towards each other. The word in the expression at the beginning was or, which means the answer could be either this one or that one. So it could be the numbers that are greater than negative 4. All the numbers greater than negative 4 goes up to 9 and continues past 9. All the numbers greater than negative 4 are all to the right. Likewise, a is less than 9. All the numbers less than 9 go to the left all the way to negative 4, and also numbers past negative 4 are also less than 9. So in this case, when you have the lines point towards each other, your answer could be one or the other. If they point towards each other and you have the word or, the correct answer would be all solutions. Every number on a number line is either greater than negative 4 or it's less than 9. And last question for the section is m is greater than or equal to 3 and m is less than or equal to negative 2. Again, these are both solved already, so we can graph right at the beginning. Our smaller number, negative 2, I'll put on the left, and positive 3, I'll put on the right. Both points are a closed circle. M greater than or equal to 3 goes to the right, and m less than or equal to negative 2 goes to the left. On this problem, we have the answers that are less than negative 2 and the answers that are bigger than 3 or equal to. The word in this expression is and, meaning the number has to be a solution in the first one and also the second one. There are no numbers that are less than or equal to negative 2 and are also bigger than 3 or greater than or equal to 3. So since there's no number that qualifies in both of these sections, the correct answer to this problem would be no solution. The special cases on these, if you have the word or and the lines point towards each other, it's always all solutions. And if you have the word and the lines point away from each other, it's always no solution. Title of the last section today is Writing an Absolute Value Inequality. For these questions, we'll be looking at a graph and working backwards to write the inequality. First question, we have a number line with negative 4 on the left-hand side, 0 in the middle, and positive 4 on the right-hand side. Above negative 4 we have an open circle, and above positive 4 we have an open circle, and we'll connect the 2 points in the middle. Having the graph of this inequality, we can figure out what the original inequality was. To do that, we know it's an absolute value inequality since we have two numbers. So we can start with an absolute value. We'll have a variable, we can use x, and the number next to x that we'll subtract is the number that's halfway between negative 4 and positive 4. So halfway between the endpoints would be 0, so we'll subtract 0 inside the absolute value. The inequality, when the 2 points are connected in the middle, the inequality is always less than, and since they are open circles, it's not less than or equal to, it's just less than. And the number it's less than is the distance from the center to either outside point. So from 0 to 4, that is a distance of 4, so it will be less than 4. Simplifying this, x minus 0 would just be x, And our final answer would be the absolute value of x is less than 4. Second question, and last question for the section.